right? So work it out. The good thing here is you don't have to what? You don't have to find the change in mass, right? They gave you the value already in use. You have to convert that to what? Kilograms and then feed that like to it, right? Give you the value. Right? And they told you what you was converted and work it out. Right, done. Right, Vishal, are you done? Right, so you'll recognize that they already give you the value for delta M. Those who online message your answers, please. I only have Vika shown so far. Right, and so the problem is we have to convert this value to kilograms, right? So delta M is equal to 0.3 0.3018 multiplied by 1.66 by 10 to the minus 27. How much is that? What's that value in kilograms? 9988. Wait, 5.009. 28 kilograms, right? That's the value in kilograms. Now you have to convert it to energy, right, Elena? So energy is equal to 5.00988 by 10 to the minus 28 by the speed of light squared by 3 by 10 to the 8 squared. Right? What you got for the value, Vishal? Vishal, I didn't work it out. Yeah, how much y'all got? 4.50. 4.51, right? After you write the exact value, then you can round off. But at the end, by 10 to the what? Minus 11. All right, nice, Shabani. Nice, Elizabeth. So after you all write the exact value, then you can round off, right? All right, good job, Elizabeth, Shabani, Petal, Naisha, Kiran, good job. Somebody else unmade, Vikash. Good job, Vikash. All right, nice. So that is your question number 1. Let's go back to our old year, 2005. Right, this is a full question. I really hope all I can see it. This is one where you have to work out delta M. Sorry. If you can't see it, take a pic. You can log in and come closer. Go ahead, have fun. Answer all cheap cards there. You all seen it? Oh,
So it's still had the old question.
What's going on there? What's going on there? Oh, sorry, earlier. I thought I'd share. I did not share it. I did not share it. Wait, what's going on there? Things take off. Hold on, earlier. Come on, take a picture for the car, see it. Right, find the number of neutrons, the atomic mass, and find the energy. Find number of neutrons. Excuse me, Christian, excuse. Please. Please, without too much trouble. Take your time, right? How do we get neutrons? How do we get number of neutrons? Huh? You don't know, Justin? Right? Remember that your mass number is always your protons plus neutrons, right? So to get your neutrons is the mass number minus the atomic number. Yeah, take your marks and move on. 3 marks, yes, that's all you're doing. So for bismuth, it will be 212 minus 83. How much is that? What you all got there? 212 minus 83 is 120. 9. All right, thanks. What's the atomic mass for Xeon? Sorry. Yeah, Eon or something. Huh? What's the atomic mass? So you have to come back in the formula and balance it off. Balance it, please. Balance the equation for artificial. Ready? Like, look at your values here. Here's 1, here's 235, here's 90, and here's how much? 3, right? Because they have 3 neutrons. So the mass of each neutron is 1. So if you have 3, that'll be 3, of course, right? So therefore, it will be 1 plus 2, 3. 1 plus 235 is equal to A plus 90 plus 3. So how much is A? How much? 143. All right. 143. Nice. Go ahead. Calculate the energy release now in the good. Yeah, each reaction earlier. Yeah, do it twice. So calculate the amount of energy released in the natural reaction and then in the next one. I just going to zoom out a little bit, right? Or in, whichever zoom is up. Look at that 2 reactions on top there. It have 2 reactions. They are natural and are artificial. Go ahead. 2 sets of working you have to do, right? Delta M, you have to find for each one. Right, so I'm going to work out natural here. Jet boy. You know where it come from, maybe begging. Tell you where it come from. Right, so you have to work out the energy for the natural and the artificial, right? Let's see what you got now. You just help me with the values, right, please? Right, so to work out the energy here, the mass of the change in the mass is the mass of the reactants minus mass of the products, right? How much reactants we have? One alone? So that'll be 211.99127 and a minus of TI 207.98201 plus 1 alpha particle. How much is that? Alpha is 4. Alpha is 4.00260. How much is that? 6. Now check again. Oh, by 10 to the okay. By 10 to the minus, okay. I think 6.5. Tell me again. 6. 10 to the minus 3. Okay. Nice. And then we have to convert that value to what, Christian? Convert that value to what? I gave you 2 steps at the beginning of the class. Kilogram. How are you doing that? $1.66 by 10 to the minus 27. How much is that? How many? 556 by 29 to the minus 29 kilograms. Okay. Okay, so that's delta M. And now we have to find energy. How we get energy again, Nishana? Right, by speed of light squared. Thank you. So that's 1.10556 by 10 to the minus 29 by 3 by 10 to the 8. And don't forget the squared. How much is that? 3.8 by not squared. How much y'all got there? Give me the exact, huh? Yeah. By 10 to the minus 13 joules. Right? That's the energy for the, right? Nice. Elizabeth have 9.004, right? I want the exact value. Right? Thanks, Elizabeth. Right? That's your value in joules now. Do the same thing and work out the artificial. But please remember, watch here, please. Please remember that you have 3 neutrons here. Okay? So you're multiplying 3 by the mass of a neutron. Go ahead, work out artificial. Finish already? Right, do the artificial there and then we continue. So we have to figure out which one producing more energy, right? And then give them the ratio, I think. That's what they asked for. Yeah, which one you recommend, the natural or the artificial? Go ahead, work it out. Let's use Siri, please. The last part. All right, Vikash finished already. Nice. Find the ratio, Vishal. I think they asked for the last part. They asked for determine the ratio of the larger to the smaller. So divide the one that produces more energy by the one that produces less. Fire check. Please. Oh, take this one, take whichever one big and divide it by the small. So you do the short energy. Yeah, big man. Wait a minute, big man. Listen something there, big man. You have one neutron. Uranium. Okay, not go wrong the token. I'll try this one out. Right, let's check out some answers online here. Let me see anything from Kezia. Let me see. Who's that? Amy Lee. Any answers there? Soraya was sending anything today? Anything from Soraya? Nope. Nothing from Kaling or Soraya. Iran, Petal, Shania, Shiloh. Don't forget me. Buduki, don't forget me, right? Buduki. Okay, Buduki. All right, let's see what we got here. I'll try that working in blue. Oh no, what just happened there? All right, so they want us to find the change in mass. That's 1 neutron, 1 uranium. So that's 1.00867 plus a uranium 235.04 393 minus 142.93 489 89.9 and 3 neutrons 1.00867. Right, need a little help there, please. But what y'all got for delta M in terms of U? 0.1844 by 10 to the. No, I meant multiply by. Multiply by 1.66 by 10 to the minus 27. That'll give us the value in kilograms, which is 3 point. That's not about it. By 10 to the minus 28. Good. So you already recognize that the mass and the mass change is larger, right? And therefore, energy is equal to 3.06104 by 10 to the minus 28. That's the change in mass. You multiply it by the speed of light squared. Take your time in the calculator, right? How much is that? Sorry? 2.754936. Ooh, I read your mind there, but. Right? So which is larger, the artificial or the natural? Artificial is larger, right? So which would you recommend? The artificial. But they also ask for a ratio. So it's the artificial divided by the natural. So that'll be 2 points, sorry. Right? They wanted to find the ratio. How much is that? Divide both of them, let's give us an idea of the ratio. What you got? $27. Right, so let's round it off like 28, right? So the ratio is 28 to 1. Yeah, 28 times the amount of energy you're getting from the artificial. Are you sure, right? 28 to 1? Okay, good. 28 to 1. Nice. So that's it for our summary of, in fact, let's do one more because if I start magnets today, you might forget. Wait, we'll be doing magnets and mechanics first. So mechanics. Yeah? All right. Most likely are doing magnets on Saturdays, right? Because I finish electricity. All right. Let's do one more like this now. Right? Next day I will do the mechanics, right? I'll do the review in mechanics. All right, let's go back to our old year. One more with a small calculation as well. Anybody writing? Excuse you, Lena. Anybody writing online? Sharvani again, Joe. Sharavani, yeah. Anybody writing? Taking it off, right? Last one. Simple one. Some of us did it already. Right, but we don't have much time, so you had to go a little bit faster, right, Vishal? Who messaging at me? Try this, please. Last one, please. Hurry up. Everybody, let's see if we can finish out this one, right? That's how I'm gonna charge on it. Hurry up, you gotta do all this capture the model and you have to, and you have to find the energy. Carbon have six electrons left. Six electrons. I expected to know that. It's a good. You're done? Just check out the shell model. Remember, carbon is already. Carbon is what? 14C6, right? Well, carbon 14. What type of carbon is that? Carbon 14. Is an isotope of carbon? It's an isotope of carbon 12, right? So how many electrons it has? It has 6 electrons, right? 2, 4. So let's do a quick little drawing here for you. All right, some of you look like you forgot about this, huh? You have 2 shells, 1 here, 2 here, 3, 4, 5, 6. Right? It's also important to let them know that here is your nucleus with 6 protons and 8 neutrons. 6 protons and 8 neutrons. Right, sorry. Go ahead, finish it up. What's the reaction, Prishal? 14C6. It loses a what? A what? What does it lose? Whatever the K it underwent. Huh? And beta is what? 0 minus 1e, right? So the new particle becomes what? 14, 7. Right, the only problem, I don't know how they kind of expect you to know what is 14, 7, right? Which is nitrogen. So learn your first 20 elements, right? So that was long ago, so I don't feel they'll do that now. It's an old year. Right, last part, please. Last part, please. Calculation, and we are done. Oh yeah, passing around to watch this last one here. Last piece of calculation here. I'm not ready to my hand. What number then? Oh yeah, do the calculation, please. Passing around. Hurry, hurry. Those who are online, you can message them, please. So 3 correct answers already. What is it? 5 plus 4. Right. Are you finished? All right, nice. Any more answers online? I have 6 correct answers so far alone online. Come on. We got some more. I have 7. Wait. I was checking wrong. That's 1. That was the old message, yeah? Y'all done? They gotta plug in your values good. I'll check it for you. That's one. Try one more time. All right, let's finish up here. Right, Elizabeth, good. Any more values? Right, so the first thing we're doing, we'll be finding delta M. So delta M is 1.007825 plus 1.008665 minus 2.014102. How much is that? How much you all got there? Hello? How much you all got there? How much you got, hey, Zin, how much you got there?
3.5.
No, not the final answer. The change in mass in U.
3.96408 by 10 to the minus 50.
Hey, Smarty, before that. I want the value, I want the change in mass in U. Yeah.
2.388 by 10 to the minus 3.
2.388
Yeah.
by 10 to the minus. And then you multiply it by 1.66 by 10 to the minus 27. How much you got there? 96. 96
By 10 to the minus 50.
kilograms, right? And then to find the energy, we use the change in mass by speed of light squared, right? So that's 3.96408 by 10 to the minus 30 by 3 by 10 to the 8 squared. And the value you got was 3.56. Well, let's round it up, right? 3.57 by 10 to the minus 13 joules. Nice, Vikash, you got that?